This is 2.5 lesson, solving compound inequalities. Your objective is you'll be able to solve compound inequalities. So for the first part, we're going to show these two different kind of equations on separate number lines, and then we're going to come back and put them on the same graph just to kind of be able to wrap our heads around this a little better. So looking at the first one, we have show x is greater than or equal to 2 and x is less than 5 on number lines. So I'm going to number my number lines. So I'm going to go, I'm going to put kind of, I'm going to build them both at the same time. That way we're able to see it a little better. I'm going to start with 0 and then go 1, 2, 3, 4, 5, 6, 7, 8. And I'm actually going to keep that between all of them. It helps us see that just a little bit better. 4, 5, 6, 7, 8. You don't necessarily have to, but I do recommend it just to kind of help you see everything happening. There may be times where that's just not feasible, especially whenever we get into the or statements, just the way that it looks. Okay, so show x is greater than or equal to 2 and x is less than 5 on number lines. So I'm going to do this first one, x is greater than or equal to 2. That tells me, okay, I'm going to put it as a circle, and I'm going to fill it in, because that's what that equal says. X is greater than, so a number that's greater than 2. What's the number that's greater than 2? 3. So I'm going to go towards the 3. And this is where it starts kind of making sense for me to only go one or two numbers instead of trying to do the entire graph. The next part of this is x is less than 5, so I'm going to go to 5. And I don't have that equals to sign, so I'm going to put a circle, and I'm not going to fill it in, and I'm going to go to the left. Now it says show these on the same graph. So I'm going to take both of those things. So I had a filled in dot here, and I have an open circle here, and they're going to meet up with each other. So you can kind of imagine me almost putting like an arrow going in this direction and this direction. This is your range of values. These are what answer your question. Okay. Oops, I just realized that I did this a little wrong, but it'll be fine. So again, I'm going to make it so that everything kind of fits on the graph. I'm going to start with this with -3, -2, -1, 0, 1, 2, 3, 4, 5. And again down here, -3, -2, -1, 0, 1, 2, 3, 4, 5. And the big idea here whenever we're doing this is we want to make sure we're able to go at least one to the left and one to the right. That way you can kind of see and do that check a little bit easier. So show y is less than or equal to -2. So if I go to -2, I have an equal to sign, so it's a filled in dot. And y is less than, what's the number that's less than -2? Is -1 or -3? -3 is less than -2. So it's going to go in that direction. This actually should say or. That was a typo on my part. Y is greater than 1. So there's no equals to sign. I'm going to put an open dot because it's at 1, and I'm going to the right because 2 is greater than 1. Now I'm going to combine these on the same graph. This is -3, -2, -1, 0, 1, 2, 3, 4, 5. Open dot, going to the right. Close dot, going to the left. Okay. That's the first part of that. Now we're going to keep going on. Plot a number on the same dime, and these ones are kind of a little bit more word problem-esque, and some people kind of freak with that. And my suggestion is just take your time on this. There's no reason to kind of get all flustered if you don't need to. So, plot the same number. A number x is greater than -8 and less than or equal to 4. So I'm going to break this up into two separate parts. So the first thing that I notice is that I have x. X is my variable. We're given that right here. That's my x. So x is greater than negative 8. So greater than is like that. So x is greater than, and then we're going to write out negative 8. This in between, so we were given a statement. So x is greater than negative 8. We're kind of on a, this and tells us that we're on a new idea, but related to what we were doing before. So we're still going to do x. So x is less than or equal to 4. So x is less than or equal to 4. Now I'm going to label these out, and I don't think I made this one long enough, so I might have to extend it just a little bit. So I'm going to go negative 9, negative 8, 7, 6, 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5. And so yeah, this invisibly comes out. Now it's visibly comes out a little farther, just so we can see it. So we're going to plot this. So x is greater than negative 8. There's no equal sign, so that tells me open dot. A number that's greater than negative 8, is it negative 9 or negative 7? The answer is negative 7. So I'm going to start that going in one direction. I'm not going to finish it until I get the whole picture. And I'm going to do this in I'm going to do this in plum. The 4 has that equal sign, so that tells me that I'm going to fill it in. And it says x is less than 4. What's the number that's less than 4? Well, 3 is. So these guys are actually going to meet up, and so we're going to actually have them connect. That was really greatly done, in case you're wondering. We could rewrite this if we wanted to, but it's not necessary. We could have rewritten this like this. We could have written negative 8 is less than x, which is less than or equal to 4. That is also an option. Okay. All right, we're going to move to the next one. A number y is at most 0 or at least 2. And there's some of the phrasing right there. At most, it's 0, or it's at least 2. And so, again, we're going to write this in two kind of separate equations. So I'm going to say, okay, I got y and I got y. That or, this or right here, tells me, okay, I'm going to have two things. So number y is at most 0. And this is kind of where some people struggle, is these at most and at least and stuff like that. And so it takes just a little second for you to say, okay, if it's at most 0, can it be more than 0? Can it be, if it's at most 0, can it be more than that? Or can it be less than that? So at most says it cannot be any bigger than 0. So it needs to be less than. It can be equal to 0, but it can't be any bigger than that. The next phrase is at least, and these kind of seem like a little almost backwards of what you want to say, but I always try and think of this as money. So your debt can be at most, or really it's at least 0, but it can be more than that. So we're going to go at least 2. That means it needs to be greater than or equal to 2. Because it could be, at the least, it could be 2, but it's going to be more than that. So I'm going to write this out. I'm going to go negative 1, 0, 1, 2, 3. I'm probably going to really just stop after I do 1 on both sides. So y is less than or equal to 0. So I'm going to go at 0. I'm going to have a filled in dot. Less than means I can go to the left. And then y is greater than or equal to 2. I go to 2. That's a filled in dot because it has that equals to sign. And we're going to go off to the right. Okay. All right. So what we need to do here is solve and graph the solutions. So I'm going to spread this out a little bit because we're going to have to do a little bit of work. This one looks a lot different from what we've seen before. So we have negative 4 is less than x minus 2, which is less than 3. There's two kind of approaches to do this. Some people are able to evaluate it just like this. Others, it might make more sense to do something more like this. Imagine these as two separate kind of equations with sharing a common middle. So this is the same as negative 4 is less than x minus 2, and x minus 2 is less than 3. So you can imagine it either way. You're going to get the same answer, you're going to get the same results. If you're doing this this first way, what we're going to do is we simply are trying to get the middle by itself. Instead of being that left side by itself, we're trying to get this middle by itself. So I want to get x by itself, so I'm going to add 2 to all of the sides. And so negative 4 plus 2 is negative 2, less than x, less than 3 plus 2 is 5. And so all the rules that we've kind of had up to this point still apply. If I divided everything by a negative, I'd still have to change the signs. Alternatively, if we did it like we did over here, negative 4, we're going to add 2 to both sides. We're going to get negative 2 is less than x. If we add 2 to both sides, we get x is less than 5. If I want that x on the left side, I just simply switch everything around and I get this. So we get the same answer. It then asks us to graph this. So in graphing this, I say, okay, let's see, let's call this 6, or actually, no, I don't want to do that. I want to start with negative 3 on the left, go out from there. Negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, and I'm going to put a 6 out here just so I can reference to it. These both have these less than signs, or sorry, these both have no equal to signs, so I know it's going to be an open dot at the 2 and it's an open dot at the 5. If you can look at this, again, I still suggest kind of imagine these as two separate little equations. So I do negative 2 is less than x, or x is greater than negative 2. So I'm going to go off to the right one. And then x is less than 5, so I'm going to go to the left one. I say, hey, these guys are meeting up. So I'm going to connect those two. So I'm going to do the next one. So I have negative 3 is less than negative 2x plus 1, which is less than or equal to 9. Now again, if this just seems really confusing to you, I suggest splitting it up. So saying negative 3 is less than negative 2x plus 1, and then doing negative 2x plus 1 is less than or equal to 9. And that's totally fine. If you wanted to do this first one, again, we're trying to get the x by itself in the center. And we're still going to kind of follow those same basic rules that we've been doing in solving equations. So we're going to subtract 1 from all of the sides. So I get negative 4 is less than negative 2x, which is less than or equal to 8. And then we say, okay, now we need to divide everything by negative 2. And I just mentioned this. If we divide everything by negative 2, we actually have to change our signs. So negative 4 divided by negative 2 is 2. Change my sign, x. 8 divided by negative 2 is negative 4. Change my sign, negative 4. This might be one where I might come and double check it just to make sure I didn't kind of mess anything up. So subtract 1, I get negative 4, less than negative 2x, divide by negative 2, divide by negative 2, I get 2, switch my sign, x. Do everything the same over here. Subtract 1, subtract 1. Negative 2x is less than or equal to 8. Divide by negative 2. X, switch the sign, is greater than or equal to negative 4. Alright, I did it right. Cool. So I'm going to go negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3. Hey, that one wound up working out for us. So I know that I'm at negative 4 and I have a filled in dot. And x is greater than that, so I'm going to the right. I go to 2 and I have an open dot. And x is less than 2, so that says I'm going to the left. And these guys actually wind up meeting with each other. All right. Oops. So the next one that I have is 3y minus 5 is less than negative 8, or 2y minus 1 is greater than 5. What you have here is they're two different equations, but they both work together. So I say 3y minus 5 is less than negative 8, and I might bring it out just a little way so I don't get it mixed up. I say 2y minus 1 is greater than 5. And so I'm going to choose one and I'm just going to solve it. That way I don't get them mixed up with each other. This is a symbol. So I'm going to say, okay, I'm going to add 5 to both sides. I get 3y is less than negative 8 plus 5 is negative 3. Divide both sides by 3. Now I'm dividing by a positive, so it doesn't switch. So I leave it with y is less than negative 1. On this right side, I'm now going to solve this one. I'm going to say, okay, I have plus 1, I plus 1. So 2y is greater than, that makes 6. Divide by 2, divide by 2. Y is greater than 3. So now I'm going to graph it. So, oops, let me give myself just a little bit of space here. So negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6. So the statement, the first one says y is less than negative 1. So I'm going to put an open dot at negative 1 because there's no equal sign. And what's the number that's less than negative 1? Negative 2. Now I have y is greater than 3. So I know I'm at 3. It's not filled in because there's no equal to sign. What's the number that's greater than 3? Well, 4 is. So you'll notice these ones actually never meet up. Alright, let's do one more. This should be the end, I believe, of the notes once I finish this one. Yep. Okay, so I have 2p plus 1 is less than negative 7. And I have 3 minus 2p is less than or equal to negative 1. Like I said, I'm going to treat these as two separate equations. So I'm going to start with this left one. Why? Just because I feel like it. So I subtract 1 from both sides. And I get 2p is less than negative 8. And I divide both sides by 2. I get p is less than negative 4. Now I'm going to do this side because I got the variable by itself. Now I'm going to do this right side. I'm going to say, okay, I'm going to subtract 3 from both sides. And I get negative 2p is less than or equal to negative 4. I didn't switch the signs because I subtracted. I didn't divide or multiply by negative. Now I'm going to divide by negative 2. And now I'm going to switch those signs. So I get p is greater than or equal to negative 4 divided by negative 2 is 2. Looks like I lost my graph on this one, so we'll just make a little rough sketch one, which is totally fine. It's not going to be the best thing in the world. That's probably a little overkill, so I'm just going to stop whenever I get to 3. So negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3. Okay, I'm going to graph this. Choose green. So negative 4, I don't have that equal to sign, so I'm going to put a circle. I'm not going to fill it in because there's no equals to. And I'm going less than negative 4. What's the number that's less than negative 4? Negative 5. So I'm going to go in that direction. Now I do this other one. P is greater than 2. So I'm going to go to 2. It has that equal to sign, so I fill in the dot. And what's the number that's greater than 2? 3. So I'm going to go to the right. There we go. So that ends your packet for today. Go ahead and check out your assignment